universalautomation.org. It's about sharing a technology, a shared runtime execution engine.
We call it a game change in the automation because we have first one technology which is based on the IEC 64099, which is the standard which aims at decoupling hardware and software.
Hardware itself is becoming very, very performant in terms of processing and CPU power, and the future is more and more about software.
This approach is really a winning approach because it's very, very flexible. You develop the application once and you can reuse in each different configuration.
That's exactly what Universal Automation and 64099 enables, because it brings a new formalism for developing software, which is object-oriented in nature and which allows deployment over distributed hardware for the actual final control system. So let's say that it's a marriage made in heaven.
So if I want to make more conscious decisions based on my business data, which also come from the automation level, I need universal automation to get this data in an efficient way and with the right engineering efforts on the level when I can do and run the analytics.
Offers are available, not just from Schneider Electric with EcoStruxure Automation Expert, but also from Advantech, from Stahl, from ESA in Italy, and from other companies.
Advantech is growing really, really fast. And I believe if you want to keep on growing in the next future, you need to be able to innovate. And when I see universal automation approach, it is exactly the way of innovation we need to go with.
Most of our customers from process automation are pretty conservative, so never change a running system. But now we see a new generation coming up, what is used to new technologies, and they are open to test, to try these new functionalities. And I think most of them pretty well understand the advantages on this. I'm doing this now for 20 years, and I think over the years, this is the most exciting changes.
And from my experience, I see that in the IT, for example, there has been a big revolution. And I expect the same in automation. I don't know when it will happen. Probably takes a little bit of time, but probably a revolution will come.
Good morning, good afternoon, everyone, and welcome to this new edition of the UAO Goes Live. Second time this week, and this time we are going to go to Austria, where we discover a bit more about tools and tool concept about 64099. And I'm happy today to welcome on stage with me the Professor Alois Teutel. Hi, Alois.
Hello, everybody. Hi.
Yeah, it's a pleasure to have you with us because for sure you are one of the icons for 64099. So sure, having you with us on stage, that's always a great pleasure. And Alois, today you will tell us a bit more about tools and tools concept. From what I understand, can you tell us more about that?
Yeah, try to give an overview of the research that we did over the last 5 to 6 years on managing big and very big 4099 applications and what infrastructure, tools, concepts for tools can help us to make engineering of 4099 solutions more efficient.
Yes, so quite interesting because as we go forward towards, let's say, application, those are the use cases that we are encountering more and more with very large applications. So let's see what you have presented, what you want to show us today, and I give you the floor.
Thank you. So, as I already said, I will talk a little bit about automation, and I would start with the downer. I regularly say nowadays something is rotten in the state of automation, and the problem that we see is that we have a software problem. I don't know if you heard about this news story. It was in many different news outlets. It was even in newspapers here in Austria. So there was a school in US, in Massachusetts. They had a problem and some glitch in their building automation system. it was a mixture of some sensor faults, which was then not very well covered by the automation system. In the end, it was a software problem. And they came up with the problem that they could not turn off any lights because the building automation system went into a fail-safe mode, and the fail-safe mode was turn on all the lights for all the time. And so they tried to trace down the company. So there were issues. Company went bankrupt and was sold a few times. In the end, they could trace down the company. And the result, what they got as an answer for the problem, they had a software problem. The result was, yes, replace all the control hardware. Let's redo the whole automation solution. And that cannot be the answer. So if we have software problems, we need to get our software under control. We need to get better control software quality. Here with UAO, it's not surprising that I would say, yeah, 4099 is the solution. So I call 4099, so this is my personal name for 4099, a domain-specific modeling language for distributed industrial process measurement and control systems. And the reason I call it domain-specific modeling language is it levels software development for industrial process measurement and control systems a level higher than the existing solutions we have. It introduces new elements, it makes development more efficient, and what's getting more and more important, especially with all the adaptivity that we need, that we have here, the distribution aspect as a core entity. In the setting that we are, I will not talk about what 4099 is, but I would like to tell you that we now have even measures. So friends of mine from Vienna University of Technology, Peter Xellmann, Martin Melik-Makumians, and Georg Schitter did this very nice work where they used code metrics that were developed to compare different solutions and different languages. And they implemented so classical sequential processes and continuous processes in 4099 and 1131 and compared them and compared the complexity. And what you can see here, that the numbers for 4099 are most of the time much better than the 1131 numbers. And this is a clear indication that we have with 4099 different concepts that are better suited for automation, that help us to reduce the development effort. But please don't get me wrong, this should not be an 1131 bashing, because 4099 heavily builds on 1131. So if you think I'm doing that, no, it's just we would like to get more efficient. And as I said in the introduction with Greg, what I want to talk today a bit about what we did in order to leverage the potential of 4099, because my hypothesis is for quite some time now that 4099 from the language perspective is very powerful, but how it's nicely said, a fool with a tool is still a fool. So we need to learn how to use the tool, how to make tools for 4099 to, in the end, get the best out of it. And what I brought here today is an overview of some stuff that we did. It's not all, but I thought I took the highlights of it. And I would like to start with control software architectures. This is something that's very important. We worked on how to structure 4099 application. One example that's from around 2018-17 is a collaboration together with VDMA, where many different companies built this cell here. So this, just fighting with my mouse. So where is it? Here it is. So this robot cell, which was assembling fidget spinners, which were famous at that time, if you still remember. And what we came up with was a structure, a very classical automation structure where control software follows the mechatronic functionality of mechatronic structure of the machine, but with the difference that on each level we had a software component representing the component. This works especially well down here for the individual components, so for grippers, axes, different actuators like vibration feeders, sorting cameras. And in that design, we offered the functionality via an vendor-neutral OPC-UA interface to higher coordination layers. And here we had then coordination activities that would coordinate the lower level entities. The advantage of that design pattern, and we could show that, is especially if you need to change lower level components, all other components are not affected. However, what we noticed also in a subsequent study is that if you need to change anything of the functionality up here, it can get very quickly very complicated. And so we came up with an idea where we said, okay, from skill orchestration to skill choreographies, where we say we have for the components still the coordination function blocks. We call them hardware function blocks here, for example, for a cylinder. And we have then so-called skill function blocks that we can then use to choreograph the functionality. And to give an example how that could look like, so here we have a capping station that is inserting caps or lids on top of small bottles. And so here, a classical sequence, if you model it in a sequence activity diagram, sorry, this is an activity diagram. The colors map to the different functions here on the left. And by applying that design pattern that Lisa Sonnleitner, the main author of that pattern, developed, then, and you rotate that by 90 degrees, you can very nicely represent the individual steps by function blocks and can utilize the power of 4099 event connections to very visually represent the activities of that machines, and changes, adaptations, variations of that sequence can done here very nicely. And while we were doing these design patterns, we came up with a research question. How do we assess design patterns? How do we know that this design pattern is better than the previous design pattern? How do we assess certain kind of quality aspects? And from that, a total new research topic here at the LIT Cyber-Physical Systems Lab emerged. And this new topic was about quality assessment of control software in general. So we focus a bit on 4099, but 4099 has so much 1131, therefore also for 1131 aspects. And we started with rather straightforward metrics like assessing the structural complexity. So this is one approach where we represented certain aspects of a 4099 basic function block in spider charts, which you can then use and compare to each other and say certain aspects can be utilized or can be assessed with that. The problem with this quality metrics is that they depend a lot on application domains, and so there is no one single source of truth. So for one domain, it could bigger application function blocks may be better than for in other domains. So here we are also looking for partners to say, okay, what would be interesting approaches. And one metric in that here is rather problematic is the lines of code, which is very often used because it's a very simple measure. So if you have a function block with 1000 lines of structured text code in algorithms, you already get a feeling that this is maybe not correct. But that's lines of code in itself is not an assessment of how complex the code is. So we investigated certain measures of investigating what kind of structured text elements are harder to understand than others. And with that, we did a survey where we showed, like you see here, an example, 2 ways of implementing function blocks and asked users what variants were better to understand. Could they understand the problem? Did they find issues? What were hidden in the code? And this resulted in something where we can go more to what's sometimes called cognitive complexity, to tell how complicated is it for a software or a control engineer to understand the code that was written. And as you know, most of the code is written once and read often, so understandability of code is something very important. This brought us to the next level, which is bad smells in 4099. Bad smells is a term that was originally coined to indicate that we have here code that is not super nice, that is not tidy, that could lead later to some issues. However, it's not wrong code. So we are not talking about that this code is broken. So this is perfectly correct code. Your machine runs perfectly fine. But bad smells is code that may lead later to problems, especially under the investigation of maintainability, long-term maintenance, or reusability. And you see here a word cloud of all the different bad smells that were already identified in industry. So the big ones is duplicated code. There is a Smith's Army knife, spaghetti code. Shotgun surgery is also a very nice one. Cut and paste programming that unfortunately is still a lot around. You see here certain examples that our first work identified. And one work that I personally like a lot is the topic of feature envy. Feature envy is a kind of measure for badly structured code. So you see here in my figure, two different modules that are interacting with each other. So on the left side, you see we have here 4 interactions. On the right side, when you would restructure the same code in different modules, you would only have one interaction between the different modules. And this is something that's very controversial because structuring code, grouping elements together is something that is very often targeted not only by just numbers, but also about what humans understand. Nonetheless, Lisa Sondland again did that work, found 2 potential ways and mapped that to 4099. One is the feature envy factor that shows how well a certain function block or a certain module is structured and how much it's connected to the outside. And then the other one is the so-called distance metric. The distance metric is even nicer because it gives an connection-wise distance between 2 blocks, and the distance metric allows even to give hints. So you could give hints to your user saying, if you would move the block into another module, your overall structure would be with less connections and maybe therefore more maintainable. We took that distance metric, and in the bachelor thesis of Philip Bauer, we took this concept. You see here a sample 4099 application structured in certain hierarchies. And what he did is he flattened everything out, so all the hierarchies are gone. And based on the feature envy factor and the distance metric with an optimization algorithm, came up with a potential solution where we minimized the number of interconnections between the modules. So as you can see on the right side, it looks much tidier than on the left side. The big drawback of that kind of optimization is that it's done without the user. So it follows only the logical connections and loses all the information about what was grouped together, maybe because of functionality, maybe because of mechatronic structure. So therefore, from our experience talking with potential users, you have to take these results with a grain of salt, thinking about how to utilize these results. Nonetheless, we got very positive feedback from first beta users investigating, telling, oh, maybe a little bit restructuring could help us to get more maintainable, because less connections make it easier to exchange, make it easier to replace certain things. One other problem in as bad smell or generally is conceived as problem is duplicated code. So we had works on identifying clones. So this would be one-on-one copies. This is, especially for bigger applications, mostly a computational problem, because we have lots of function blocks and connections, and you have to do lots of comparison operations. We came up with a very efficient way of finding clones in bigger application. What I brought here is even a step further. What you see here is a graph representation of a rather big 4099 system. You see here certain isolated parts. So I don't have the exact numbers, but we are talking here with a few thousand function blocks and a few 100,000 connections. And what you don't see is that we have here similar structures. So all the circles with the same color are duplicated code. And in that sizes of function blocks, you not really see that easily. And so Mr. Unterdechler did that as part of our work in the Christian Doppler Lab basics that I mentioned here. So what we did is we turned our 4099 applications in graphs. We did similarity embeddings with graph neural networks and feature embeddings, and do then some projection and clustering. So classically, what nowadays are called classical AI algorithms. And the output of that algorithms are these nice graphs showing similarity. So here you see similarity groups and some thresholds. I personally like this kind of figure a little bit more, although that looks more fancy. And what you see here is all the circles that you see here are different modules of our graph here. And if two circles are very near together, it means that these are similar. And so if you take here a circle from here and down here, it would be something completely different. Something like these here, or the cluster up here is something that I, as maintainer of that application, would look into and see what are similarities and differences. Can I group stuff in new types so that I get more reusability? When the people showed me the first results, they were not convinced, and they showed me some similarity things, and I found this quite nice because as a control engineer, I could immediately see what the similarities are and what not. So having tools like that can really help to find duplicated code, find similar code, which can later be refactored, reworked to help us getting better maintainable code. We work also on language extensions. What Greg did not say, since 2008, I'm also in the 4099 standardization committee. Since 2015, I'm somehow the convener of the 4099 working group. And as part of that work, I'm also interested what are the limits and the problems of 4099. So if you find these kind of things, I would be happy if you drop me an email or send me some kind of message so that I can get that. And we work on language extensions or investigating certain boundaries of the language. And one thing that is something that is investigated by different researchers is about, can we provide more information for tools and users on how to use function blocks? One approach would be so-called interface contracts, where you specify in some way the intended use of your function block. One way, like shown here, could be the service sequences of 4099, and we investigated, can the service sequences automatically be translated into some formal methods to check if the interface is correctly implemented, if an interface is correctly used. And this worked quite nice for the very limited use case. We are currently looking forward to get this to another stage. And but also what we could show is that service sequences in its current form have limitations and definitely need more. And that led us to more research done by Bianca Wiesmeyer. She investigated in her PhD thesis what can we do to better help users of 4099 to either specify the behavior or assess the behavior of 4099 elements. And if you look here, these are what currently is offered by 1499. So we have execution environments, we have function blocks, we have sub-application composite function blocks and applications. We can specify some way with service sequences the component behavior, but to be honest, everything that is added to that picture is somehow missing. So we don't have a very good way of specifying behavior of networks, execution environment, which would be really needed to do that. As a first step to get here further, we started with interpreting function block models, which is a new approach to addressing 1499 in tools. So what we developed here is a function block run. We call it runtime, although it's not a very good name for that, because we are directly interpreting the application that you develop in your tool without the need of any additional software. So you can assess the tool that you can assess, sorry, not the tool, you can assess your function blocks, your ECCs, your function block networks inside of the tool, and having all the freedom and possibilities that you have on a powerful PC or laptop. And you don't need to do all these classical things like I develop my function blocks, I develop my application, I compile and deploy to the runtime, I start the runtime, I watch what's going on in the runtime, and then go back and improve. So you can have here very short round trip environment. And from that, what we can get from that is that we first of all can utilize that for comparing implementations. So we already use that in work together with Luleå University on comparing execution behavior of different runtime environments. We can do platform independent testing. So we on that level, we can already develop unit tests and integration tests for function blocks and function block networks and get code coverage, how much of your 1499 code is covered by the test. We can even execute partial models. So even half of your function block is ready. We can already investigate, test, evaluate that without that you have to fully implement that. This greatly improves development round trip times, understanding of your code. So we got very positive feedback on that. We can test without any limitations, so with nearly no limitations except from tool infrastructures. So we can do much more on that. I already talked about round trip times, and language engineering is something for that. So coming from the more generic things also to tools, and I already said we need great tools. And if you look out there, not only our new target audience, we heard it in the beginning, the workforce is changing, our users are changing, but not only that, what we need to leverage and assess the power of 1499, we need complete new tools. We need tools that are more powerful, that know a lot about what you want to do. And 1499 knows about a lot of things, and tools that utilize that power can help you. And what we are trying to not only develop the theoretical concepts, we are also developing tools and tool infrastructures. One thing that we are working on, and where we show many of the things that I have shown you today, is available as part of the Eclipse Kodiak project. So you find here the link. If you Google it, you can download it. And there we show certain concepts of 1499. Also, we are investigating additional new features, but also investigating advanced tool concepts like the assessment of code quality, and also other things that I would like to show you later now. So one thing that we noticed for especially very large projects with lots of elements is that you're very often limited to certain levels of complexity that you can see. Either you get very big sheets with lots of function blocks, or you structure them in sub-applications and composite function blocks. But this, in German, we have this saying of about trees and woods, and you don't see the wood because of all the trees. So you are totally lost in the details. And Lisa Sondleitner, together with Philipp Bauer, developed a concept where we try to show these big applications and all the connections, what's going on in a dedicated visualization. So what you see here is an output of a sample application that we developed to test the tool. Here you see 8,000 function blocks and 45,000 connections between these function blocks. And this is not a view to develop, this is a view to get an overview, to assess, to visualize. So we have also concepts to enhance the view now with metrics like code quality issues, or we can visualize the direction of connections. So is a lot of stuff. So you see here lots of things are coming out of that point, going in different directions here. So it would be interesting if it's bidirectional, unidirectional. So we have already additional concepts with that. But developing tools has a big problem because tools have users. And there was a very nice keynote 2 years ago by Brian Selig. It had the title, "What's Wrong with Users?" And in the end, it's very important to note users are never wrong. That the users just don't understand what you thought, and then it's maybe a problem how you develop the tools, what tool concepts you use. And therefore, we already spent quite some effort also in how can we help tool developers to build better tools by assessing their usefulness with developers and users. And this is quite interesting. This concept was developed originally by my colleague Rick Rabiser. And we applied this concept and other concepts to different usability studies. And the core part is not only assessing it with users, so this would be the right side, the light blue side, but also the medium blue side here, which is also involve your developers and your tool concept developers in the assessment of the tool. And one thing that I would like to especially point out here is this cognitive dimensions assessment. Cognitive dimensions assessment is based on an assessment developed by, sorry, I don't have that on that slide. People from UK, I can look that up if anyone is interested in that, which was developed to help tool developers as well as language developers to assess how hard it may be for users to use it. And in these cognitive dimensions, there are certain assessment methodologies, like how much do a user need to remember, or one of my favorites is pre-major commitment. So pre-major commitment means, do I need already at the beginning decide which path I take, or do I get different ways of assessment? Or if I made a mistake, how easy it is to repair, or how easy it is to change? And this drove a lot of thinking when we developed future tool concepts. And that brought us up to one of the first things that we noticed is that regularly, because of different people developing libraries, function blocks, applications, we ended up with inconsistencies and errors. And you see here some examples that could help, like someone deleted a type, renamed the type, remove the pin, change data types. So these are very prominent things that regularly happen. Tools can help us to protect, but sometimes you need to do these steps in order to further develop your application. And if we would protect the user from doing that, it would mean that there is no chance to go to the final result the user would like to have. And this is going into pre-major commitments. So if the user is not doing the right steps in the right order, they will never come to the right outcome. And with what we are doing here with handling inconsistencies, that we say, we accept that a 4099 model may be broken. It can be that pins are missing. It can be that certain stuff is not here. From all the information that we have in our data, we show the user as much information as possible to allow to repair that, so that it's not that it's first of all readable again. So previous tool, I know some tools also we were like that broken models were just not loaded and you were lost, everything was gone, or you had to manually, in these prototyping tools, repair that in the XML files. This is not something a user wants to do. What we came up with is this concept of classical error markers, like if you would have a compiler error, if you have a wrong C++ or Java program, then also the compiler tells you, here you need to fix something. So we are not currently also investigating, can we fix stuff automatically? But very often we see from the trust point, users would like to repair or get informed about what is done. So therefore, with that, we can show users, look, someone did something that was not okay, or it was intentional, but you now need to repair something. And repairing, changing code can be hard, and therefore we also have a PhD thesis ongoing, which is looking into refactoring operations for 4099. So refactoring is changing code structures that make the software easier to understand, better to maintain, without changing functionality. And sometimes, or what we are investigating here is what options of classical refactoring operations are available that we can apply to 4099 and implement in the tool. So you see here an example screenshot where a function block, the child block, is just moved out of the containing superb. All the connections are correctly updated, all the interfaces correctly updated, and I just say move to parent or move somewhere else, and I don't need to take care about all the steps that I would need to take. And that's something which really relieves the users. And we did a study, so how we can define refactoring operations even independent of the language. So you see here an example of Simulink. So there was some work on Simulink on doing that kind of work. So we learned something from Simulink, but also we came up with currently 52 refactoring operations. Not all are yet implemented, but many of them you can find now in Foliac IDE. And we also found refactoring operations that were originally that we developed for 4099, which we saw could be implemented also in other languages. So that's something for people who are implementing different languages, different kind of tools. Yeah, and with that, I'm at the end of my overview. I hope it was enjoyable. The classic question in the end, are we there yet? Unfortunately not, but still we are a big step further. So I hope you find that interesting. We would also like to get your feedback on certain features, how we can improve it, things that we may forgot in our investigation. And therefore, I'm very happy to have that been able to present here. And Greg also said it would be nice to announce this thing here. So after more than 6 years, we are now again offering the 4 days of Eclipse Foliac Winter School. It will be in Linz here, in somewhere around where I'm currently sitting, in the LIT Open Innovation Center of the Johannes Kepler University. And this winter school will be all about 4099, Eclipse Foliac and UAO runtime, Opus UA, and anything that you make out of it. So if you find that interesting, drop us a message. On the Foliac webpage, you find more information of what already is available. Registration will open soon. So I hope to see many of you there. And with that, I'm at the end of the talk, and as now everywhere has to be something with ChatGPT, I have here a poem in the style of Goethe on 4099. And with that, I'm ready for your questions.
Thank you, Alois. Thank you for this great presentation and all the work which has been done, in fact, on the topic. That's always interesting to have a view of where people are thinking to go, especially in terms of research, and as well to see the possible application behind. I see that we have two questions already. So let me just show them directly on the screen. So excellent research work from Kozanda. What is cyclomatic complexity? Please explain more. So this came quite at the beginning of your presentation.
Yeah, cyclomatic complexity is a complexity measure introduced quite some years ago. The cyclomatic complexity assigns all the elements in your code a certain kind of complexity and adds that up. So if you have if statements, so if you have nesting, if you have operands like plus, minus, multiplication, function calls, these all add to a certain kind of complexity. And the more you have, the bigger the complexity is. Cyclomatic complexity is something that that was introduced to compare and assess also how much cognitive effort it is to understand. In the meantime, cyclomatic complexity got not the biggest reputation, and people are now going towards more cognitive complexity. Cognitive complexity is most famous presented, and I think it was also developed by Sona, so this famous code analysis company. And they describe it a little bit more. They are focusing more on nesting and hierarchies, which tell how much cognitive load this kind of code has on your brain. I hope that helps. So it does not make sense that I bring up the formulas, but roughly in that direction it is.
Good. Thank you, Alois. Next question from the same viewer. When you measured the complexity of the code, did you focus on the complexity for programming or complexity for the user for troubleshooting?
Ooh, this is a hard one. I would say we mostly measure the complexity of the code that is there. So it's mostly for the people that later need to read and understand the code. I'm not sure if there is any measure that would be on the complexity of developing the code, because developing the code requires some additional things. So you need to first understand the problem, break the problem down in steps, and then write it down. And I think for most of the development tasks, the first steps that are not resulting in code but understanding the problem are normally the biggest complexity, and they are independent of the code. I'm not sure if there exists a measure for measuring how much effort it is. So there is a measure for how much effort it is to type. This is especially when you compare Python with Pascal or BASIC. So this depends on how much you have to type. But here, modern tools with code completion and code assists can help. So I would say definitely we focus on the resulting complexity of working with the code later on. Because in the end, especially in automation systems, when this code is maybe around for quite some time, definitely the effort is on maintaining reading understanding. And there are studies out there that also for normal code, that more time is spent on reading and understanding code than writing the code.
Good. I see one last question came. Are you suggesting to use machine learning to identify repeat patterns and assess their need, as well as reusability? If so, how practical is it to integrate the tool into EAE build? So I think two questions in one. Let's start with the first one.
Maybe even three. I like the question. This is really a nice one. we are definitely strongly investigating different kind of, I would say, AI algorithms. I'm not sure machine learning is a different story. This could be recommender systems. I think that would be a total topic by itself. But yes, I definitely see that we live in a world where lots of copy, paste, modify code is done. And so repeating patterns is a thing. We have a dedicated research project that I was allowed to present today in the morning in a UAO session, where we focus on variability and how different codes, the implementations are similar or not. And 1499, because of the mixture of textual in the algorithms and graphical and with the graphical programming languages, need different ways of doing this assessment. So a pure textual is not working very well. A pure graphical is not very well, and therefore a mixture using graph neural networks and similar things is definitely something. We just had a paper last week at EDFA on that topic. Annalena Hager, one of our AI students, is in that direction. And then we could investigate saying, maybe when then the algorithms better understand what our code is doing, we could go into the next step and going towards recommender systems. Something like, I see that you do the certain thing, you already have a block in your library. Would you like to use the library block or not? But I don't know how fast we're getting there and if that's possible. For integrating into EAE build, our tools, so that AI, that graph assessment tools are currently separate tools. They just work on the 1499 XML. So this would be independent of any tool. And I currently have no idea how well they scale. So maybe this kind of tools would work better like in build and integration tools, where you have a build server where every night your whole code base is analyzed and then you get dashboards and can investigate that. From personal experience and also studies, I know that the quicker the feedback to the user, the better the code quality. But that's something which is hard to say. Maybe then EAE gets a connector to the build server and shows problematic code with error markers or something like that. This could be something to be investigated. I'm also happy to discuss with EAE build developers about collaborations on that.
Yes, sounds great. So
great AI world.
That is more and more coming anyway. So that was it for the questions for today. We had a very great and very detailed session. So that's very interesting. For the viewers here, you can see the details of Alois directly written on the screen. So feel free to reach out. I think as well his LinkedIn page is linked to the event. So don't hesitate to just reach out to him if you have any additional question. And for the rest, we'll close the session for today. So thank you for being with us. Thank you for watching. And then see you soon to the next session of UAO Goes Live. Bye.
Bye. Thanks for having me.